Hi, this is Jeff with Room to Discover, and today I'd like to share a few tips for incorporating project-based learning into middle school math. If you're interested in student-centered learning, please check out my website, roomtodiscover.com, and follow my Facebook group at Room to Discover. So the question comes from Dana from Newport, Kentucky, and she writes, do you have any ideas for how to fit one and two step equations into a planning a trip PBL? So let's look at some ideas. Project-based learning, simply put, is learning by doing projects as opposed to giving direct instruction, lecturing, or just reading from a book. Another thing to think of, though, is that if everybody's project looks the same, then it's not really project-based learning. So we're leaving some room for students to explore and create something unique. So I put these down as some general steps involved in a PBL experience. First thing is to set goals. So we want to share with students what the learning standards are, whether there are other non-academic parts to it, such as teamwork, right? We might also be doing this to try to establish teamwork. Now, in this case, the primary goal is to solve one and two step equations, but there might be some other goals depending on where your students are in their experience as collaborators or their social emotional learning. Next is guidelines, which is closely related to the goals, but this is where, as the teacher, you're providing some support about how they're going to get there. A rubric is a great way to introduce guidelines. There you're helping them understand how they're going to be evaluated, and it gives them some guidance as they go to the next step, which is to explore. So in this instance, we are considering going on a trip, so we might have students work in groups and think of ways they might use math if they were planning a trip. Now, we're also going to coach, so we don't just set them loose and 2 weeks later, right? Because a PBL project should be something that happens over a certain period of time. It's not usually a one classroom experience. So as they're working with their teams, as they're exploring, we're checking in and we're coaching, we're giving feedback on where they are so far, and maybe helping out if they have questions. Another key element to project-based learning is to present, and this can be standing up in front of a classroom and talking about it. It can be hanging something up in the hallway, posting it on a blog, some way that the product that students are creating is not for an audience of one, right? The teacher is the audience of one, and generally students are submitting just to a teacher for approval. Part of the philosophy of PBL is that they're presenting to a wider audience. It makes the learning feel more authentic, it's more motivating. And then finally, there's a reflection, and that could be part of it, at least, should be self-reflection, but it can also include feedback from others, and maybe as a class we're reflecting on this whole experience. So let's look at some ways that we could use real-life examples regarding a trip in creating a project for one and two step equations. So here's an example of a two-step equation, and what makes this a two-step equation is that it's going to take two steps in order to find a value for x. So we're still working with just one variable, but there are two operations involved that we'll have to undo, right? We've added 200 on here, and we've also multiplied x by 35. So an example scenario that could be related to going on a trip is that we have a fixed cost such as renting a bus or renting a venue, right? We're going somewhere, and this is a base cost no matter how many students go. And this is a per student cost, right? So our unknown is going to represent the number of students, and 830 represents our total cost. So if we don't know how many students are attending the trip, but we know what the total cost is, we can figure it out, right? First thing we'll need to do is take away 200 from both sides, and we end up with 630 equals 35x. Next, in order to find out what x equals, we'll have to undo the multiplication and divide both sides by 35. Now, there are many ways to do this, but I'm always in favor of using some type of mathematical reasoning. And here's my mathematical reasoning here. I know that 2 35s makes 70. 10 times as much of that is 700. So 35 will go into 720 times, but 630 is 70 less, so that's going to give us 18, because 18 is 2 less than 20. So I know that 18 students are on the trip. In our next example, let's say we have 2 hours for our trip, and I've started out as 120 minutes instead of 2 hours just to get rid of a step. We've already converted to minutes. And the travel time is 15 minutes each way. So it's going to be 30 minutes of travel time. And we're going to a tightrope walking center, and it's going to take 15 minutes for each student to walk the tightrope. So in this equation, again, my unknown number is students, but it's not the total students necessarily. Hopefully everybody gets to walk the tightrope if they want to, but we're trying to figure out, we have a restriction, 120 minutes, that's our total on this side, and in order to find out how many students can walk the tightrope, first we're going to have to take away the 30 minutes of travel time, and then we're going to have to divide what we have left by 15. Now, part of the beauty of using real-world situations like this is it explains why, in order to undo this operation, we have to take away the 30 first, right? Why not just divide by 15 over here? Well, this is our travel time, and that's not affected by how long it takes each student to walk the tightrope. We're going to add those two items together to get our total, right? But I can't go ahead and divide by 15 students. First, I need to take away the travel time. And this shows us that we'll have 90 minutes on site for 15 students to go. Again, I'm going to use a mental math method in order to divide by 15. And I know that 2 15s is 30. So 2 students will be able to go in 30 minutes, and 90 is 3 times 30, so that's going to be 2 times 3, which means that 6 students will be able to walk the tightrope. Now, sharing these examples is really just the start, right? This might be where we're starting to set the guidelines for our students. Ultimately, if we really want this to be a project-based learning experience, students are going to come up with their own problems. Hopefully by modeling how to solve some two-step equations, they'll get the understanding of how two-step equations works, but they're probably likely to forget it or maybe not understand on a deeper level. But by going through the process of working together, creating their own scenarios, presenting it to the class, and then reflecting on the experience, we're likely to get a much deeper level understanding and hopefully some increased student engagement. If you have any questions, please feel free to shoot me an email, jeff@roomtodiscover.com, or post it on the blog, roomtodiscover.com, or check us out on Facebook at Room to Discover.